Good morning, dear students. Today we'll discuss Introduction to Atomic Structures. How the structure of atom is described by different models. What are the learning outcomes? Explain different atomic model to describe structure of atom. Describe Thom's plum pudding model and its drawback. Discuss Rutherford-Giger-Marsden experiment. Explain Rutherford's atomic model and its limitations. So first of all, we'll discuss what is Dalton's atomic theory. So according to Dalton, elements are made up of small particles which is called atoms. So that means according to Dalton that every matter is made up of small particles that is called atoms. Atoms of a given element are identical in size, mass and other properties, and atoms of different elements differ in size, mass and other properties. According to Dalton, atoms cannot be subdivided, created or destroyed. Atoms of different elements combine in whole number ratio to give compounds. In chemical reactions, atoms are combined, separated and can be rearranged. So Dalton is known as father of atom, and Dalton's theory is the foundation of modern theoretical chemistry. Then after Dalton, Thomson is another scientist who gives a model regarding the structure of atom that is known as Thomson's model. So according to Thomson, atom is like a Christmas pudding. In home we are preparing cake, and in cake we are giving different dry fruits. So here this cake, base of the cake is plum and the dry fruits are pudding. So here according to Thomson's model, so that is like Christmas pudding. That the pudding means the base of the cake is the pudding and the dry fruits are the plum. Similarly, the atom is, the pudding is a positive charge and the electrons are like the plums. The electrons are the negatively charged, which are like plums on the pudding. According to Rutherford, he proposed that here you can see that this is a positively charged. Okay, in this positively charged pudding, there these electrons are like plums. Okay, so that means here you see there are so many vacant free space. So many free space is empty in the structure of atom. That means Thomson told that this atom is a positively charged sphere where the electrons are embedded inside this positively charged sphere. According to Thomson's model, what he told, atom consists of a positively charged sphere and the electrons are embedded in it. And what he also, another assumption he told that the negative and positive charge are equal in magnitude. Whatever negative charge and positive charge present inside the atom, that is equal in magnitude. So the atom as a whole, it is electrically neutral. But this Thomson's atomic model somehow describes the structure of atom, but it cannot totally describe the structure of the atom. There are so many scientists who done different experiments to give different atomic models. This Thomson's, the drawback or the limitations in Thomson's model, it was carried forward by Rutherford, a British physicist Rutherford, who gave an experiment, who done an experiment, and he proved that whatever model was given by Thomson, that cannot totally describe the structure of the atom. Then let us see what is Rutherford's atomic model. Before that, just we'll describe the problems or drawbacks in Thomson's model. Thomson's atomic model failed to explain how the positive charge hold the electrons inside the atom. It also failed to explain an atom's stability. Okay, the theory did not mention anything about the nucleus of an atom, where the nucleus is present. And also, it was unable to explain the scattering experiment of Rutherford. Okay, that means after Thomson, Rutherford in 1909, Rutherford and three different scientists, Rutherford, Marsden and Giger, they have done a gold foil experiment in 1919, who they disproved the Plum's pudding model. They told that instead atom is not a soup of positive charge where electrons are embedded. They disproved this model. They found that inside atom the positive charge is situated inside the center of the atom, and the electrons are revolving around this positive charge. According to Thomson's model, whatever the Thomson told, that atom is like a positive soup. That is, the atom is a positive charge where electrons are embedded in it. But the Rutherford model totally this Thomson's model also gives some idea of taking which Rutherford gave his experiment. But whatever the limitations, whatever the drawbacks in Thomson's model, that was carried forward and that was advanced by Rutherford. Let us see what is this Rutherford Gagadan Giger Marsadan gold foil experiment. See, so in his experiment, they have taken a alpha particle. Source is here alpha particle which is inside a lead box. And this lead box has a slit. Why in his experiment he has taken alpha particle? Because alpha particle is positively charged and also alpha particles are, but this is a heavy mass, it is a heavy in mass. Okay. So, according to Thomson, we told atom will consist of positively charged sphere. So, he has taken a gold foil, thin gold foil. Why thin gold foil? Because we will take a thin gold foil, it will consider around 1000 of atoms. If the number of atoms will be less, then we can get the concrete result in each experiment. So, in his, we pass this alpha particle through a gold foil, and here you will see in this we have taken a, this is a screen and this is a fluorescent screen made up of zinc sulfide. What is the need of screen? When we will pass the alpha particle through the gold foil, when this alpha particle will fall on the screen, it will appear the fluorescence, as it is a fluorescent scene, so flash lights will appear on the screen when this alpha particle will fall on the screen. Because according to Thomson's model, Thomson told that there are so many vacant space inside the atom. So when this alpha particle will pass through the matter, through this thin gold foil having different atoms. So as there is vacant spaces, so this alpha particle will pass through the thin gold foil and that will fall on the screen, and this, when it will fall on the screen, it will show the flashlights. But in this experiment, when he done this experiment, he found some different result. What what give him conclusion to disprove the rather this Thomson's model? What he found in his experiment, let us see. He see that when he pass this when this alpha particle falls on the gold foil, some of the alpha particle will hit the screen and the some of the alpha particle will just reflected with some angle, and some of the alpha particle will rebound back. So that means he was astonished why this happens. That means there is something inside the atom. Why some alpha particles are reflected with some angle? Why some alpha particles are rebounded back? So from this alpha particle scattering experiment, Rutherford what conclusion he drew? What he observed that most of the alpha particle passed straight through the gold foil. That means there is some vacant space inside the atom. Okay. Then some of the alpha particles are slightly deflected by small angles. That means this atom is positively charged according to Thomson, but when this alpha particle also positively charged, when it close to these atoms, they will deflected with some angles. But very few alpha particles it appear to rebound. That means when this alpha particle will come in this solid positive charge, they will rebound back, they will repel back. As we know, same charges repel each other. So, after this experiment, what Rutherford model gives us? According to Rutherford model, what conclusion he has drawn? Atom consists of two parts. One is nucleus, another is extranuclear part. In nucleus, it's positively charged and it is a small solid sphere which is present inside the center of the atom. That means almost whole mass of the atom is concentrated in this small region. When the alpha particles come in this directly hit this nucleus, they are rebounded back. When they come closer to this, they will reflected by some angles. Okay, so that means there is a nucleus inside the atom which where the whole mass of the atom is concentrated, which is positively charged, and there is a extra nuclear part. In this extra nuclear, this is the space around the nucleus in which electrons are revolving at high speeds in a fixed path. That means according to Rutherford model, we conclude that atom consists of a nucleus and an extra nuclear part. In extra nuclear part, electrons are revolving around the nucleus in high speeds. So, based on this observation, Rutherford proposed a model of the atom which is named after him. So, according to it, atom has a teeny dense central core or the nucleus which contains entire mass of the atom. Other having rest of the atom almost empty, and the diameter of the nucleus is very small, like 10 to the power minus 13 centimeter as compared to that of the atom. The entire positive charge of the atom is located in the nucleus, while electrons distributed in vacant space around the nucleus. That means he told that the electrons are moving in orbits or closed circular path around the nucleus like planets around the sun. So, what you see, what is the difference between Planck's model, Thomson's model and Rutherford model? Thomson's model definitely gives some structure of atom. The Thomson's model will give more idea about the structure of the atom. But the concrete information what the model, whatever the limitations in Thomson's model, that was carried forward by Rutherford. There is also Rutherford's model also describes structure of atom, but it cannot totally explain the structure of the atom. Then some other scientists also done different experiments to describe the structure of atom. After Rutherford, Niels Bohr also in 1913 he also gave a model that is known as Bohr's model. Whatever the limitations in Rutherford model, that was carried forward by Bohr, and Bohr explained a model that is known as Bohr's model. Let us see what are the limitations in Rutherford's experiment or Rutherford's model. So, according to we know classical electromagnetic theory, when any particle, that electrons are negatively charged particle, when that will orbit, electrons will revolve on in a circular orbit, they will get accelerated. So, during acceleration, this charged particle will radiate energy. When this charged particle will radiate energy during their revolution, they will lose energy. So if these electrons will lose energy, that means these electrons will fall into the nucleus. If the electrons will fall into the nucleus, then the atom will become unstable. But we know that atoms are stable. Okay. So this defect, why these atoms are revolving in this circular orbit and they are radiate energy. Why atoms are radiate energy? Whether atoms are radiate energy when you are they are revolving in a fixed path or circular orbit. So these defects in Rutherford model that was proved by Bohr. That was again explained by Bohr in his model. We will study Bohr's model. So for this you can follow different books. So this is Essential of Physical Chemistry, Arun Bal and B.S. Bal, and you can follow J.D. Lee, and also Modern Inorganic Chemistry by B. Douglas and M.C. Daniel. Thank you.